Well, perhaps we'll go ahead and get started so everybody can get to dinner or wherever they're going after this virtual meeting. So the way that we've done these measurement rules, so we've had three stakeholder meetings, we've had three in person so far. We've had, and sorry, I guess I should introduce myself before I jump into this for people that don't know who the folks you see on the screen are. So my name is Jason Ullman. I'm the state engineer and the director of the Division of Water Resources. James, do you want to introduce yourself?
Sure. My name is James Heath. I'm the division engineer here in Division 5 out of Glenwood Springs.
And Andy?
Yeah, good evening, everyone. My name is Andy Nasevich. I'm an attorney with the Colorado Attorney General's Office.
Marie?
Yeah, good evening. Marie Sullivan, DWR's Compliance and Communications Specialist.
So, sorry, I started off without introductions, but so the way that we've set up 6 stakeholder meetings, 5 in person and then 1 virtual. And so this is tonight, obviously the virtual meeting. We've had Grand Junction, Edwards, and Kremling last week, Monday, Tuesday, and Wednesday. And then after this meeting, we have November 12th scheduled in Frisco and November 17th scheduled in Glenwood Springs after the Basin Roundtable meeting. So if you would like to attend an in-person meeting, we still have 2 coming up after this one, if you don't get your questions answered here. As far as housekeeping for questions, what we're going to do is we're going to do a presentation. The presentation, it goes over why measurement's important, what the rules are, and kind of a broad perspective of that. And then we will actually open the rules up and go through the rules. And at that time, we will open it up for questions. During the presentation, if you have questions, you can add them by going to the, I'll call it the tic-tac-toe, the tools button at the lower right-hand corner of your screen. Marie has pinned a chat that explains how to do this, but if you go to that, you will find a Q&A where you can ask a question. And so you can type a question, and if something hits you while you're here listening to the presentation before we open it up for verbal questions, you can type it into that Q&A section. Okay, so you want to next slide? So I think something that I feel like is important to do as we start these meetings, because we have a variety of different people with different experience with the Division of Water Resources and water use attend these, is start off with why are we talking about measurement rules? And so the first thing I think to explain that's helpful is that Article 16 of the Constitution, state's Constitution, is where we adopted this prior appropriation doctrine as the method for legal framework for allocating a public resource. So the water of every stream is hereby declared to be the property of the public, subject to appropriation as hereinafter provided, and priority appropriation shall give the better right between those using water for the same purpose. Why is that important? Well, because if you have a water right to take water out of the natural stream, out of the ground, you're taking the public's water and using it for some purpose. And so that's why, the state and Division of Water Resources is involved in administering the prior appropriation system and making sure people with vested rights that are senior are getting the rights that they're entitled to. Next slide. So in doing that job, which James will explain a little bit more in detail later, measurement is kind of important, right? And so there's 3 main reasons why measurement is important that I want to explain tonight. And the first one is intrastate administration during a call. So a senior water right on the stream makes a call for their water right, which is essentially that water right holder or owner contacting our office to explain that they are not receiving the water right they're entitled to. And we then go out and administer or curtail people's rights. So it's important for us to have good measurements so that our staff can maximize beneficial use within the prior appropriation system and protect those with water rights. The second reason is compact administration. So in and across the state of Colorado, we have 3 basins where we do pretty regular compact administration, and that's the South Platte, the Arkansas, and the Rio Grande. And measurement in those basins has been pretty important to make sure that we are complying with our interstate obligations, but also protecting people's right to use water that they're entitled to under those interstate obligations. In the Colorado River, we haven't had to do any compact administration per se because Colorado has been in compliance with the compact since it was signed in 1922. Under no measure have we been out of compliance, and so we haven't had to do any curtailment. But as many of you on the line know, you're here because you're interested in water use. You know that the hydrology hasn't been super great the last 25 years, declining supply, increasing demand results in increased calls and potentially larger calls like a compact call that could extend across up entire streams, main stems and things. Those things are really hard to administer and make sure we comply with without good measurement. And I've mentioned the example that I'm most aware of that I started with the Division of Water Resources in Water Division 4, which is the Gunnison River Basin. The Gunnison River Basin, a large water right at the bottom, is called the Redlands Power Canal that can call out the entire basin. And then until 2002, that right had not placed a call. When they did call in 2002, which was a really bad water year, the division staff were in the position of having to send orders out to hundreds of structures that didn't have good measurements so that we could make sure we were maximizing our administration. So it's really difficult to do that in an emergency. These rules are one way to be proactive about that need. And then for data, we actually have a statutory obligation to record the usage of water in the state of Colorado. What is the public's resource being, who's taking it, and what are they using it for? Diversion records are required to be submitted by the division offices to the state engineer every year. But also that data protects water users during intrastate or compact administration. So it protects your individual water rights during administration. It also protects you from potential abandonment proceedings, which is a statutory process that we're required to go through every 10 years. So these are kind of the big 3 reasons why measurement is important. And so this is a reference from statute for the owner's responsibility to provide maintenance or provide measurement and a head gate. And so I want to note in red, the language in red where it says the owners of ditches shall erect where necessary and maintain in good repair a suitable and proper head gate. So that where necessary is important. Next slide. So the measurement rules are effectively a way to define through a stakeholder process where people can offer comments and we can provide a consistent and reliable standard for where measurement is necessary, when is measurement necessary, when is a head gate necessary, what constitutes an adequate measurement method, and that means essentially what is the accuracy standard that we're going to apply when we look at a measurement device to decide whether it's accurate enough, and then a process and a timeline for evaluating the adequacy. The statute requiring owners to put in measurement doesn't include some of that more specific information, even though it does require the owners to install and has been around for over 100 years, that statute. It doesn't provide that kind of more consistent and reliable definition for those things. So that's what measurement rules will do. Where do they not apply is another important distinction or thing I want to explain, because if you're on a ditch system, say a large ditch system in the Grand Valley in Division 5, for instance, it could be a mutual ditch company somewhere else as well. that has a number of laterals and you're down one of those laterals and you take water off of that lateral. These measurement rules do not apply to those laterals off of those ditch systems. They apply to the place where the water is diverted from the stream. So where the public's resource is taken out of the stream or out of the ground for use. So there's a lot of systems where, you may have tons of laterals that distribute the water across a large area of land. And we're mostly interested in where they take the water into that main canal. There's also exceptions in the rules, and we'll get to this in more detail when we go through the rules themselves, for domestic wells, for exempt domestic wells. So these are wells that take 15 gallons a minute or less for domestic purposes. And then some other exceptions for ponds that have limited purposes of livestock watering, wildlife watering, and fire protection. And then surface water diversions, which primarily would be springs that don't exceed 15 gallons a minute and are used for limited domestic purposes. So that is kind of tied to that exempt domestic use exception, but we'll cover the exceptions when we go through the rules in more detail. Next slide. So I'm going to turn over to James to talk a little bit more about what his staff do for administration.
Thanks, Jason. So most of our streams in the Colorado River Basin are snowmelt fed. So we get a good snowpack during the wintertime. Then in the spring, it starts to melt. And most of the time, there's not a call if we've got a good snowpack. But later in the season, there's less water available than there is demand for that water. So we have to administer the water rights in the prior appropriation system. So in this example, we've got a stream system that's flowing down this direction. We've got a junior upstream water right, a 1970 water right, and a senior downstream water right. So when the senior water right at the bottom of the system doesn't have enough water, they've got a proper head gate, a flume, and they're sweeping the stream, they'll generally call our water commissioner and request administration. Our water commissioner will go out in the field, evaluate the system, and generally we'll go upstream and turn off junior water rights if it's a valid call and we need to do our job and administer the river system. Next slide, please. So how do we go about doing that? I've got 3 different examples that I'll walk through. Here we've got 3 ditches. Ditch A has got an 1880 priority. Ditch B's got an 1875 priority. And Ditch C has an 1895 priority. So the senior water right is Ditch B. The next senior water right is Ditch A. And the most junior water right is Ditch C. But in this example, none of these structures have measuring devices. So if Ditch B claims that they're only receiving 80 CFS and they're 120 CFS short, how do we know that? How do they actually know that? They're lacking a measurement device. So in this scenario, when none of the structures have measuring devices and we're requested to do administration, we can't do it accurately. So we're not going to honor the call because they haven't met their statutory obligation to have that measuring device in place. Next slide, please. So in this next example, Ditch B then goes out and gets their measuring device. So they now have a measuring device in place. So my staff can go out there and see that they are actually only getting 80 CFS of their water right, and they are 120 CFS short. However, Ditch A and Ditch C don't have measuring devices. So we still don't know what they're taking, but we do have a downstream senior priority placing a valid call, and we do need to do administration to ensure that they get their water right. So generally in these cases, what we will end up doing is curtailing both Ditch A and Ditch C to ensure that Ditch B is getting their water right. And only in rare cases will we then later allow Ditch A or Ditch C to take water if we can accurately verify that there's more water going past ditch B than they actually need for their water right. So let's go on to the next slide and talk about the third example when everybody has a measuring device and we can accurately, reliably tell how much water is being diverted by each of these ditches. So when all three ditches have measuring devices, ditch B places their call again for their full 200 CFS because they're 120 CFS short. Now our water commissioners can go up the system and first look at ditch C and see that they are taking 100 CFS. They're taking their water right and no more. But at this point in time, we do need to curtail their full water going down that ditch. Assuming no ditch losses or gains in the system, that full 100 CFS will be turned back to the river and delivered down to ditch B. So ditch B is now getting 180 CFS. So we're still short at ditch B. So we need to go up to ditch A and curtail them back down to 30 CFS to get that other 20 CFS down to ditch B. So assuming, again, no gains and losses in the system, we've now got 200 CFS going to ditch B, satisfying their priority. 30 CFS can still be diverted by ditch A, the next senior priority, and ditch C is fully curtailed. So in this scenario, we would have a call on the river system with an 1880 priority. Next slide, please. So what does the division engineer and my staff need to be able to administer a water right? When somebody goes out to the stream, diverts water, and places that water to beneficial use, they have a water right, but they're not yet in the priority system. To end up in the priority system, they have to go to water court and adjudicate that water right. So the first step is to get a decree defining how much of their diversion, the dates of beneficial use, appropriation, adjudication, a location for where that diversion is going to take place, and a definition of what the beneficial uses are. So once we have a decree from the water court, we can now place them into that priority order and administer them accordingly. In order to control the amount of water being diverted from the stream, we need to have good headgates or controls to ensure that if administration is necessary, we can turn the water back to the river system. We also need measuring devices to be able to understand how much water is going through that diversion structure. And we also need to verify where that beneficial use is taking place. So maps for irrigated acreage or boundaries for municipalities. Next slide, please. So let's first talk about a headgate. What is a functioning headgate and control structure? It needs to be easily adjusted. So we need to be able to, in each of these cases, we've got slide headgates with, generally you can use a wheel or a wrench to open those up. Generally those work well for our water commissioners. When it's a tarp and dirt that's being used to control the stream to push water down the ditch, that's not very easily adjusted. We can't make fine-tune adjustments to get the right amount of water to the priority that that ditch has. The next item we want to talk about is the measuring devices need to be reasonably close to the headgates. If the measuring device is a mile down the ditch, it takes a long time for that adjusted headgate or that flow to then work its way down the ditch and be measured at that measuring device. Our staff can't spend all day adjusting one ditch, so it does need to be a reasonable distance from the headgate. The last item needs to be lockable. So in this example, you might be able to see a chain. That's typically how we lock these headgates, the slide gates, with a wheel, is we put a chain on it after we've adjusted it and place our lock on it if we're taking control of that structure. Next slide, please. Marie, are you able to adjust the slides?
Are they not moving forward for you, James?
I'm not seeing anything changing. I'm still on what's on a functioning headgate control structure.
Interesting. Okay.
Jason, are you seeing anything different?
No, it's still on what's a functioning head gate.
Okay.
So I'm assuming that's what everybody else is seeing as well.
Go back one, please. So we've got two examples of head gates here. A bad example, which is what's being shown here, where that head gate is, it's not really controlling the stream. It's not controlling the amount of water going down the ditch. It can't be easily adjusted. It likely can't be locked in the current setup that it's in. The next example, go ahead, please, Marie, is a good head gate. We've got a good set of wing walls, concrete wing walls, separating the ditch downstream, which we're looking at, and the river, which is on the other side of those wing walls, as well as two slide gates that have wheels at the top that we can make adjustments to. We'd like to see most of our structures looking this way. Not all of them are this large, though, so you've got to get into some context on what a half CFS ditch might need versus a 50 CFS ditch, like in this case. Next, next, and I believe this is now to Jason.
Thanks, James. So we're going to talk a little bit about three terms that are in the rules here in more detail. So these are three terms that are defined in the rules. And so the measurement methods is the overarching term for any method used to measure water. We split that into, the rules split that into measuring devices and alternative measurement methods. Measuring devices is kind of what it sounds like. It's a device, physical structure put in the ditch to control the water in a way that produces a stable relationship between either the level in the flume, weir, whatever, and the flow, or velocity and flow. An alternative measurement method is anything other than that we would accept as a measurement method that's accurate enough. You'll see in the rules later that alternative measurement methods, and maybe I could talk about it, they require more frequent verification because there's not a control structure to control the relationship between the two things. So next slide, please. So what are typical measurement devices? And so you see here a kind of list of many of them. The one that is probably the most common is a partial flume. It is shown here and here, I guess. And so it is a structure that was, and I'm a graduate of Colorado State University, so it was developed by Ralph Partial, and we like to say we're partial to the partial flume at DWR because we can have the same structure has a table of stage discharge relationships that our commissioners carry around with them for all the different widths of it because it's so common. We also have a tool on our phones now, the phones that we provide for our commissioners, that they can calculate the flow for many of these different structures. But so some of the other ones that aren't as common but are out there and are adequate devices. Cutthroat flume is a flat bottom flume. You'll see here a ramp flume actually is these two structures here are examples of ramp flumes. They are custom designed, and they're accurate. Sometimes they're good for situations where you don't have as much head or drop and need a flume that will work without that, or need a flume that will fit into a custom situation. And so they a lot of times will get constructed custom either out of concrete or steel. But in those cases, you'll see in the rules, you have to provide the custom rating table to our staff, because a par-shell flume and some of these weirs, like a V-notch weir, a rectangular weir, Cipolletti weir, have standard rating tables based on empirical data. That's a V-notch flume. Some of these others are maybe not as common, but so anyway, devices that cause a change in the flow characteristics. So we call that a control, and you'll see the drop. So there's a drop here in the flow. So it's going from a slower flow to faster flow over that weir. Same here, and same with the V-notch. Those are what we call a control. That's what provides the good relationship between stage and discharge, and which is why we want to see flumes maintained. Next slide. And I'm not as good at this annotation. Erase everything. Let's see. There we go. So this is a test in the in-person meetings. It's obviously easier to say which one is properly installed. Well, neither of them are properly installed. So in this case, installation is important. So if somebody tells us, well, I do have a flume, why are you asking me to put one in? Well, in the one case on the left, obviously it's not measuring all the flow. There's more flow than the flume is measuring. In the case on the right, the flume's not measuring any of the flow, and so probably also not going to meet the standard in the rules for a properly installed device. Next slide. So now here's the test, but I'm just going to give you the answer, since I don't believe anybody can actually offer their comments unless you want to put it in the chat. But so the one on the left, you know, has a drop, you can see, but it isn't measuring the entire flow of the ditch, because something's either there's material built up in the ditch above it. The one on the right has a drop. It's got still water up above it, so you can read the staff gauge on the flume, and it is not submerged. So it is that's a good installation. Next slide. And so this one is a similar situation, but a different reason for why it's not working. You see on the one on the left, looks like it's got a good drop. You can see the staff gauge here. That is where the commissioner or the user is going to measure how much water is going through this flume. And it looks like it's pretty still, so you can read that, and there's a good drop. So I'm going to assume this one's level, because I don't have a showing level on there. The one on the right, you can see the water is just flat. It's kind of running through there just like the ditch, because there is what we call a submerged condition, and that can be caused by a lot of growth sedimentation down below that backs the water up through the flume. It can be caused by having the flume set too low in the ditch. But for whatever reason, it's not properly installed or maintained. So in the rules gives the, you know, there's some specifications for maintenance and installation. You might get a notification that this needs to be corrected, or your commissioner might tell you, you know, you really just need to clean out the area downstream of this flume, and then it should work properly. Next slide. So alternative measurement methods is the other term, maybe the less preferred but acceptable measurement method. And click the next for the most common one for these, at least for surface water and flow or open channel flow, is a rated section. And a rated section is a section of the ditch or a stream where we have measured it enough times, or it's been measured enough times at enough different flow rates, where you can develop a relationship between the level in the ditch or stream and the flow that's going past that spot. So as you might imagine, without the control, that doesn't stay as consistent. And so it might move, especially if it's a stream. But even ditches tend to change that relationship without the control. And so that's why these alternative measurement methods require verification every 4 years. And the picture that just came up is a picture of a ditch in the Uncompahgre Valley that uses a rated section. So we do have some places where rated sections have been used historically. This is in a trapezoidal ditch that stays fairly consistent. It's pretty flat, and so a flume is pretty hard to put in. It's also a large location, but you'll see the hydrographer there that was measuring the flow. There's a acoustic Doppler boat that you can barely see there in orange on the left side of the picture. The other maybe common alternative measuring method for pumps, for well pumps and things, would be a power consumption. So if you have a pump that is in good repair and you have the pump curve for it that has the relationship between the power that it uses to the flow that it can produce. Also, there's a head differential that is involved, but that can potentially be used to calculate the flow rate in a pipe system. So those are a couple alternative measurement methods, but next slide. So I'm going to turn it back over to James to explain how to measure a staff gauge and go on to some recording and reporting requirements.
Thank you. So as Jason mentioned earlier, for some of our known structures, in this case, this is a partial flume. We've got standard rating tables that we can utilize. Our water commissioners have field books that they take with them with several rating tables. This one is in particular for a 2-foot partial flume. And it's got a relationship of the gauge height to the flow rates. And on the staff gauges, we read in feet, tenths of feet, and then hundredths of feet. And on the staff gauge, there's a little arrow on some of these black lines that you can see that points to, Andy, can you still hear me?
Yeah, I can still hear you,
Okay,
James.
my computer just flashed on me, so I'm having all the technical fun tonight. So we've got tenths of feet that are marked at these little arrows on the longer black lines. So if we go down to where the water line is at, and I've lost my annotation tool, so I'll try and explain this as best I can. You can see the little flag that's pointing to the 5. So up above, we can see 1 foot, but down below, that's going to be 0.5 feet. Then if we work our way to the bottom of that longer black line, that would be 0.49. The top of the next smaller black line is 0.48. The bottom of that same black line is 0.47. And that's roughly about where the water line is. It's in between 0.46 and 0.47. So if we work our way over to the table on the left, the staff reading red arrows pointing to 0.47. That gauge height relates to 2.48 CFS and a 2-foot partial flume. Next slide, please. So why record and report diversions? First off, it's important to the water user. The measure of a water right and the value of a water right is the beneficial use, the historical consumptive use generally of that water right. One important measure is the historical diversion records that goes into that quantification of that historical use analysis. So if you've got good historical records, it's a much more reliable historical consumptive use analysis that you can create from that, along with information about the ditch on conveyance efficiencies, application efficiencies, whether it's flood irrigation, sprinkler irrigation, or drip irrigation, and then the crops that you're growing in the growing season. So there's a lot of data that goes into that. but that information generally starts with the diversion record. Diversion records are also where we start when we look at our decennial abandonment process. The first piece of data that we look at is the last 10 years of daily diversion records. And if the maximum diversion under that ditch equals or exceeds the water right for that ditch, that falls off our list right away. And it really only has to be one day where that occurred in the last decade. If we don't have any diversion records, then we're definitely going to take a deeper look into what was going on at that ditch structure over that prior 10-year period. So whether the water commissioner is collecting the data or the water user is collecting the data, if it gets into our database, that's valuable information to keep your water right off of any abandonment proceedings in the future. Optimizing operations down ditch, if you've got multiple users, especially like a mutual ditch, if you know what's being diverted off the river, you can then distribute that water proportionally to the other users down ditch. It's valuable to the system as a whole. We use diversion record data, crop data, and climate data to evaluate consumptive use and losses across the entire basin for providing data to the Upper Colorado River Commission to ensure that we are complying with the compact. And as Jason mentioned, we always have been. So that's valuable information for surface water modeling that goes into that, and consumptive use analyses as well. Transparency, when a ditch is measuring their diversions and providing that information to other entities, it builds trust in the system. There's a known measurement of a reliable device that's being broadcast, whether it's on our website or users sharing information with each other or having a third party provide that information on the website. And we've seen systems, and Clear Creek is a good example in the South Platte. And then there's ditch systems that were put on telemetry down in the Rio Grande. And once one ditch on that stream system was put on telemetry, several other entities and ditch owners jumped on board and did the same thing. It prevents a lot of finger pointing and blame that shouldn't be given to entities. And it allows for that transparency of what each of those ditches are diverting. And when multiple parties are looking to do that and share information, it often allows for cooperative efforts to gain funding for those type of operations, stream-wide or basin-wide. Next slide, please. Let me see if I can get these annotations back. So this left image shows a little radar installation. This is what we're going to in a lot of our installations on ditches and stream gauges. What it does is it measures the water elevation where the staff gauge is in that flume. And we can collect that data multiple times a second and aggregate it over a 15-minute interval and figure out what the average flow was at that time based on that stage discharge relationship for that flume. Our water commissioners have historically used field books out in the field to collect data and wrote those down and typed them into their spreadsheets at the end of the year for their published record. Marie, hit forward once, please. And as Jason mentioned before, we've got smartphones with our water commissioners and a field data app. So more often than not, they're going to be collecting the data now electronically. So once they get back into cell service, that data gets pushed to our database automatically. And our diversion records that we're collecting are then broadcast to the CDSS website and made available to the public. So that information is real time as well for when they make that field observation and then get back into cell service. On the right side is more of a setup for a large ditch system. One of the examples Jason showed would be a large ditch system or our stream gauges, where we've got a stilling well and there's intakes that allow for water to move back and forth between the stilling well and the ditch or the stream. And then a float that rides on the top of that water in the stilling well that's then connected to a recorder, and then that data is then transmitted via satellite every hour. So we get 15-minute data once an hour that we can download and look at. Next slide, please. So we've talked about some of the typical reporting types. The water commissioner visits, that's where we collect a large number of our observations and diversion records. Data recorders, which we can download, or data recorders that provide that information via telemetry. We also do accept user supplied data and work with your individual water commissioner on how they would prefer you to provide them data. If you're providing it to them via text message, email, phone call, paper, spreadsheets, anything that works for our water commissioners will work for DWR as a whole, because they're the ones that will compile all that information at the end of the year. We do also have a diversion record submittal tool that we've built online. If that's something that you're interested in, please contact your water commissioner and they can get you in touch with our office staff and get you set up to provide that information once a month, once a quarter, once a year of all your diversion records that you've collected throughout the season. Next slide, please. And I'll pass it over to Andy to talk about the water court process.
All right, thank you, James. Yeah, so this is, these are going to be legal rules with a legal binding effect, and there's a legal process for those to go through. So right now we are in the initial public outreach and stakeholder input phase, where we are presenting these, the rules and providing drafts of the rules and listening to input. And once that process is finished, then it goes to the water court. And that process works a lot like your ordinary water court application in some ways. In a lot of ways, it's a bit different. So once the rules are finalized in the stakeholder outreach process, Jason will sign those rules as finalized, and then we will file the rules with the Division 5 Water Court in Glenwood Springs. We are required then to publish those rules in the Water Court resume, as well as publish the rules in local newspapers in Water Division 5. After those have been filed with the Water Court, people can protest the rules, so basically kind of object to them, right, and become a party to the water court case. Those protests are going to be due by the second month after the filing, a lot like a statement of opposition in that deadline, for example. Once we've received any protests to the rules, then my office asks the court, the water court judge, to set case management deadlines, like setting a trial date, setting deadlines like expert disclosures and deadlines for expert reports, those sort of things. We do then work with parties, to try and reach stipulations to the extent we can. But if that doesn't happen, then the court will have a hearing or a trial. And the court will then decide whether to approve the rules or remand those back and send them back to Jason, basically, for changes. Go ahead, Marie, for the next slide. So I'm going to segue here a little bit and talk about some funding available for the installation of diversion measurement devices. The state of Colorado has secured $7 million in federal funds for the installation of free measurement structures. The way this is going to be set up is an application-based program. So if somebody is interested in taking advantage of that, they would apply to the CWCB. Those applications would be reviewed by the CWCB with DWR, along with facilitation by CWCB's contractor. And then those applications would be selected, and those measurement devices would then be installed free of charge of the water user. This is limited to the West Slope divisions, and we're trying to divide between those 4 divisions a rough about 25% in divisions 4, 5, 6, and 7. Next slide, please, Marie. So here's kind of the timeline we're looking at. So measurement rules have already been adopted in Division 6 up to the north and Division 7 to the south. Those rules are in effect with deadlines either that have passed or that are coming up. So there is a prioritization as far as the timing to focus on those 2 divisions starting this year. So applications are going to open up in the fall, with installation beginning in the spring in Divisions 6 and 7. Like I said, though, we are going to make sure that, we're not going to be spending all of the money in Divisions 6 and 7. We're going to reserve roughly half still for Divisions 4 and 5, and the applications for those would be opening up next year. And then as we're kind of going through the process, the funds need to be spent and the program done by 2029. So we'll have a rolling application process is probably the most likely result through those additional years. Go ahead to the next slide. So here's that specific kind of round 2 for Division 4 and 5 where you're at. So there would start to be outreach meetings. Those are going to be starting here in Divisions 6 and 7 in the upcoming month. For Divisions 4 and 5, those meetings would start in summer 2026. Then the applications would be open in fall of 2026. It's federal funds, so there's an environmental review process, which is going to be handled solely by the state. It's not going to be, we're making sure that it's going to be a really limited process for the water users, and that sort of review process will be handled by the state. But then with the installations for those structures beginning in spring and fall of 2027, again, with the kind of the program rolling and continuing through 2029. Next slide, please. So here's, so even though applications aren't going to be open for 4 and 5 this year, there is a statement of interest form that's available online that you can fill out. This will allow you to get notifications, when these meetings are coming up, when the applications are open. It also allows the state, the CWCB and DWR to kind of gauge what the interest is, if there are certain sub-basins that warrant prioritization, that sort of thing. So there's a QR code you can use in the next slide here. That you can go to. Marie has the website for the program, cwcb.colorado.gov /diversion measurement. And then also an email you can reach out if you have any questions, DNR_diversion measurement @state.co.us. Next slide, please. Okay, so getting back into the particulars of the measurement rules. So I talked about the water court process. That's kind of where we end up getting to. Again, we're in that stakeholder public outreach process. So Jason mentioned the meetings that we've been having and we'll continue to have in November. And that's to get feedback from people who are interested and have comments or concerns about the rules. Marie is going to share a form that you can use to submit comments online. You can also review and download and submit red lines or comments to the Word version of the measurement rules if you'd like. That's available on the DWR website under the Division 5 page. We are asking, so we can continue moving forward with this process, if you have any comments in your written comments, to provide those by December 19th. And after we've gotten those comments, after we've done these stakeholder meetings, DWR will review those comments, take them into consideration, and amend and modify the rules where appropriate. To the extent there are any major substantive rules, we will potentially be providing an opportunity to review those amended rules, and then we move forward to file them in water court. Yeah, and I'll turn it over to Marie.
Yes, so if you would like to be put on the notification list for updates on these rules, please email me. My email is there on the screen. If you have questions or comments, you can email Jason and James about them. And then the website link right there will take you directly to the location on the Division 5 website where the rulemaking information is. There's going to be a little gray box. You have to click on it. It's called Rulemaking. Division 5 measurement rules. You have to click on it. It's called an accordion, and then you'll see all of the information and the table with all of these documents, and as well as a link to the QR code and this or a link to the comment form. This QR code will also take you to the comment form. If you do not have a Gmail account, you cannot use the the comment form. So in that case, please just email your comments to me, Jason, or James, and we will let you know if we receive them. And Jason, I think I'm going to open it up for questions if you would like to
Sure.
handle all of that.
So I think that's the end of our presentation slides, at least. Marie's going to bring up the actual rule text that we can go through. But before that, well, it's up already. So if you have any questions in general about the presentation, I mean, you can go ahead and ask them now. Otherwise, as we go through the rules, I find it's, rules have to have a specific format to them and stuff. So it's helpful if you're not used to dealing with state rules that to go through them in plain language. But any questions about the presentation and the slides we just went through?
Also, please use the raise hand function rather than just unmuting if possible.
Daniela, hopefully I pronounced your name correctly.
Yeah, I do have one question regarding your definition of off-street and on-stream reservoirs. What happens if the reservoir or lake or pond actually has qualified for both of those categories? Which way would you go?
If it's a pond that qualifies both as an on-stream and an off-stream, is that just making sure that?
Correct, because it's partially taking the water from maybe the ditch that's running into it, diverted water, and partially it's sitting on stream. So it's kind of getting water from all the sources.
So I think in that case, it would have to meet the requirements for the on-stream reservoir, because the on-stream reservoir requires an outlet that we can release any out of priority inflows. So if their stream is on call and that pond or reservoir is not in priority, we need to be able to release it, whereas an off-stream reservoir doesn't have that same requirement. Does that answer your question? And we actually will go through the specific rules for both of those types of reservoirs here in more detail.
Oh, thank you. It did.
Yeah. So maybe we'll just get into the rules here.
We do have a quick question in the Q&A.
Okay. Let's see. So the question is, for those of us who've been measuring flows and diversions and submitting that data to Division of Water Resources, do we need to have our measurement methods approved as stated in the rules? And that's correct. I mean, we will confirm if your device has been used and your commissioner hasn't informed you that, the device is not acceptable and you're submitting data, it's likely that it will be considered acceptable, and we'll get to the rule that talks about what is considered a properly installed headgate. And James is saying yes. Does that mean that you know what structure they're talking about?
No, I was actually responding to Marie in our chat if the
Oh.
text was larger.
Sorry. There's too many things going on. Anyway, so I think that likely you will get a notice that it is acceptable, or get contact from your commissioner that it's acceptable if that's the case.
And Jason, if you don't mind me stepping in, I think that's certainly the idea, right? Is DWR has a database of structures that already have measurement. If you've been reporting your diversions, you'll be part of that database. And the idea and concept is for DWR to reach out to people, if it shows you already have adequate measurement, and say, hey, you're in good shape, you don't need further approval under these rules. I do want to qualify though, if you do not receive that, please make sure you're being proactive. It is ultimately going to be the water user's responsibility to ensure that they're in compliance with the rules, that they get that approval. So, it's certainly the idea that we're going to try and make this as streamlined as possible for people who already have it in place, but just to recognize that, it is ultimately the water user's responsibility.
Yeah, thanks for that. distinction, Andy, because we'll cover that briefly in the rules, but it is the owner's responsibility. But James's staff are already actually performing some of the inventory of structures to try to accomplish that. But I think in our in-person meetings, James has made it clear that there's 10,000 structures estimated in Division 5, and so there may be some that get missed. So if you don't get a notice, please talk to your division staff. So the first two rules are required as the title and the authority, but we're going to kind of skip over those because they're not probably something that we need to spend a lot of time discussing. The first one that is probably helpful to explain what it means is Rule 3. And Rule 3 defines the scope. And so the scope of these rules, as it says there, apply to all surface water diversions, groundwater diversions, storage, release, and delivery of surface water and groundwater located in Water Division 5. And then it goes on to say with the following exceptions. And so there are these exceptions that I briefly mentioned in the presentation. First one there in 3.1.1 is permitted or unregistered wells that operate pursuant to the provisions of Section 3792-602. What does that mean? That means exempt wells, 15 gallons a minute or less for domestic uses. 3.1.2 is the exemption for ponds for the limited purpose of livestock watering, wildlife watering, fire protection, or any combination thereof that are not filled by a diversion from a natural stream. So those are ponds that potentially are a spring pond, or they're a pond out that doesn't have a ditch flowing into it, that doesn't have a natural stream flowing through it, that are for those limited purposes. Those are exempted from these rules. Head stabilization ponds that are part of conveyance and application of water. So those are ponds in a ditch system that might be used to stabilize the flow in the ditch, to put a pump in, that don't store water for more than 72 hours, which is our rule of thumb for what we allow for these kinds of structures without needing a water right. Those do not need to be measured either. The surface water diversions, including springs that are diverted at not a rate exceeding 15 gallons a minute. So those and be used for the purposes of domestic use, and those additional language there about 3 single-family dwellings, fire protection, watering of domestic animals, and irrigation of not over 1 acre of home lawn and gardens it's the same description of domestic use for an exempt well in that statute. Erosion control dams, dewatering of geologic formations by withdrawing non-tributary groundwater, facilitate or permit mining of minerals. And then the last one here on 3.1.7, there is a rule in Rule 9 that we'll talk about briefly that allows people to declare their structure in writing to the division office as inactive. And I won't get into those details since we'll talk about it more when we get to Rule 9. And then I think I mentioned this language on the purpose. The purpose of the rules is to establish consistent and reliable standards to assist the state and division engineer in the administration, distribution, and regulation of water. So while we already have the authority to require or order people to install measuring devices as required by statute for the owners to do, this is intended to provide some consistent and reliable standards for that, so people know what to expect. And the other, scroll down to, I think, Rule 4. Oh, maybe something I haven't mentioned in that last rule, 3.3, may answer a question we've had. So if the rules don't relieve any owner or water user of obligations to comply with terms and conditions in decrees, rules, permits, or orders in other areas. So if your decree is more restrictive than these rules, you still have to comply with the measurement that's required in your decree. So we'll cover just a few of the definitions that are pertinent and maybe not obvious. We already covered alternative measurement methods, control structures. is an interesting one because it is essentially referring to the structures in a recreational in-channel diversion that control water within the channel and for an intended recreational in-channel purpose. Diversion and diversion structures, I think, are fairly self-explanatory. Flow rates. Inactive diversion we'll talk about later. We've already kind of talked about head gates and what's required there. We'll talk about notice later, the rules on notice. So on-stream and off-stream reservoirs, we're also going to talk about. So keep going. So other structure is one of those additions that if there's something else that's necessary for us to administer water, so a structure operated to release water from a reservoir or return water to the natural stream, deliver a measured amount of water for any purpose that's subject to administration, distribution, and regulation by the state or division engineer, including waste ditches or wasteways. And so if there's those structures on your systems that we need to be able to administer the water, they would fit into that other structure category. Qualified tester is one that I think bears some explanation related to who can verify that a structure is accurate. And we'll get to the accuracy standards here shortly. So we have hydrographers in the state. So James has 3 hydrographers that work for him in Division 5. Those people, those staff go out and measure streams, keep up our gauges, make sure that they're running and measuring accurately. They also go out and, at the request of commissioners, to check diversion measurement. And so many times, if we go out and do an inventory of a structure and there's a question on whether it's accurate or not, they're going to ask the hydrographer to go out and measure it. If an owner either questions our measurement or they want to do their own, the rules do allow you to hire somebody to test and verify the accuracy of your structure. They need to be a qualified tester as defined in the rules, which is intended to be fairly encompassing of anybody that is competent in the use of the measuring equipment that you would need, like a acoustic Doppler velocity meter or a current meter. We're not setting up a certification program. When you submit those verification measurements to us, we will be looking at the data that's submitted to make sure that it appears it was done correctly. So if there's a note that was taken as the measurement was being made, the calibration, which we'll talk about briefly, for that device that you used, if all those things are adequate, we will accept it. Recording devices are, the devices James was showing you or explaining some of the different kinds of devices that can measure water consistently and continuously. Reservoirs, let's see. I think that's it for the definitions that bear explaining. So Rule 5, that one, it's fairly short, but it's pretty important. And so, especially for administration. So this is where we define the headgate requirement, and it's not long, but they must allow the water commissioner or owner at the direction of the commissioner to accurately adjust the diversion of water with reasonable effort. So if it's like completely stuck open or shut, that's not reasonable effort. If you need a backhoe to shovel in the ditch or you need a tarp, that's also probably not gonna work in terms of meeting the requirements in these rules. And it within a reasonable amount of time, and that's James already kind of went into detail about having your measuring device close to the headgate, and then it must be able to be secured at the adjusted condition so as to prevent any unauthorized diversion or adjustment. And so that is lockable and controllable, is what you'll hear our commissioners typically say, is your headgate must be lockable and controllable. But that provides a little more definition than what's in the statute on what we accept. So The big rule, the longest rule in these is Rule 6, and that's where you find functional standards, so the accuracy standards. And so we're going to start at the 6.1.2. Diversion structures or other structures with proposed flow rates greater than 1 CFS. For those structures, the measuring device must accurately measure flows to plus or minus with 5% throughout the normal operating range. So designed to accurately measure flows means that, you know, you have a partial flume, and we'll get to the properly installed flume allowance later. If you have a flume that's designed, a partial flume, it's constructed to the right dimensions, it's installed level in the ditch, both directions, it's not submerged, then we're likely, based upon a later rule, going to consider that an accurate device. And if we have a question, we may go, the division engineer might ask a hydrographer to go out and check it, but that plus or minus 5% range, there may be a little bit on the installed there. We've had questions about this. If it settles and it stays in that settled condition, James has indicated that, you know, there's a possibility that we would adjust, you know, do a shifted rating table for that device and accept it. But not if it's just, you know, constantly changing every year. It's, you know, if it's a consistent, you know, change or consistent shift. For diversion structures that have or propose flow rates less than or equal to quarter CFS, 613, greater than quarter CFS and less than 1, they must accurately measure flows within plus or minus 0.05 CFS. And so the reason that it's not a percentage there is because 5% of that of quarter CFS is much smaller than we could actually measure. And then for diversion structures measuring less than a quarter CFS, very small amounts, the division engineer can approve the accuracy standard based upon the case-by-case situation at that structure. 615 is the requirement that the measurement device be located within a reasonable proximity of the diversion structure. Division 616 shall be properly installed and calibrated to engineering specifications. 617 shall be maintained by the user in a condition that provides accurate measurement. So that's your properly installed and maintained. The device is no good if if those two things aren't occurring. And then I talked a little bit about these custom flumes. So if it's a regular partial flume, we already have that table. If it's a custom ramp flume, the device isn't considered acceptable until we get the custom rating table for that device. So now we get to off-stream and on-stream reservoirs. So the on-stream reservoir requirement, and we already had this one question related to this, but has these 3 requirements. So you must have an outlet or other structure capable of releasing all out of priority inflows. So if you're out of priority, we must be able to pass that through. And then you must have a measure of the volume of water in storage, which would typically be a staff gauge and a stage capacity table. And then you need to have a way to measure the releases from storage. Those releases are typically being made for some purpose for delivery downstream that we're also tracking. And so those 3 things, those 2 things would allow us to calculate, if we know what's going out and we know the change in storage, we can calculate what's coming in. So that's for the on-stream reservoirs. For off-stream reservoirs, it's a little bit different. We've got 3 potential options here. And so an off-stream reservoir is one that doesn't have a stream going through it. It sits off the stream, it's filled by a ditch or some other method. And so we could control that and keep water from flowing into it without having an outlet. So typically they do have an outlet if you're releasing it for some use, but sometimes I think there are some that have pumps in them and things like that. But they must have two of the three things listed here. You must have a way to measure the amount delivered to the reservoir, so a flume on the ditch or a weir on the ditch or device. A way to measure volume and storage, so staff gauge, stage capacity table. And then the third option is a device to measure the releases. Why is it 2 out of those 3? Well, same reason that knowing the volume coming, the volume going out and the volume in the reservoir change is adequate for us to calculate the other components of that. If you know it's going in and it's off channel, and we know the change in volume, we can calculate what's going out. And if we know what's going out and the change in volume, we can calculate what's coming in. The last statement here in that 6.1.9 is for the limited situations where you have a pond and that pond is not releasing water and having water delivered to it at the same time. And so if that's the case and you're only delivering water in the spring and then the delivery stops, maybe you're out of priority, maybe it's full and you turn it off, and then you're releasing it later in the season, you could fall under this caveat that if that's the case, just knowing how the storage is changing can help us calculate those other two values, or it can help you determine how much is going in or going out. Problem is, if there's both of those things going on at the same time, we can't do that. So it's all about being able to administer and know what's going on. So I've gone through quite a bit here without any questions. I want to make sure that people don't have any questions up to this point. Yeah, Daniela?
Yeah, I go back to that 6.1.9. I don't see your math behind all this, but I would say that if there is no required measurement out of those three to measure the level in that reservoir, then there is probably some hole in the system for you to figure out the how much is getting in, how much is getting out. And I think it should be the required component in that rule to always get the water level in the reservoir, because it gets very tricky. You know, you got the rain, you got these natural sources, those are unmeasurable. And if I have a choice, if I have a pond and I have a choice to choose from those two, I can figure a way to go around and you won't get a right measurement. And I would challenge you on this question, but I don't see the math behind, but I would really think that if you want to have a good control of all water in the Colorado, I think that should be mandatory for the reservoirs to have that measurement stick in there to measure the water levels. Thank you. That's my just 6 cents.
Thanks. So you're saying that 6.1.9.2 should be required rather than an off-stream reservoir being able to measure the inflow and the outflow only.
Correct. To have a easy way to get a good picture about the whole water inventories in the state.
And I think, so these are pretty similar to the rules that we've promulgated in divisions 6, 7, and 4, that the feeling was that, if most of those off-stream reservoirs, the primary component of the inflow is what's coming from the ditches. There may be some precipitation that falls on it, but that's a fairly small component, but I appreciate the comment.
The thing, for my example, right in my HOA association, we have a pond and water is running into it from the ditches, but not the way that you can measure it because it's in the middle of irrigated field. So,
Well, and if that's the case, then they would likely need to use the, 6192 plus plus the release. So, I mean, that's going to be part of the acceptance of the measuring methods is if you're not able to measure the inflow, then you can't use that as an acceptable measuring method. Does that?
it
Makes sense.
does. It's so easy to put the stick into the pond and get very accurate measurement of the water level. It's so hard to get a good measurement of through those flumes, and because it's so inconsistent. So that's what I think that the why not to go with the requirement to use the measurement that can be very accurate as the mandatory requirement and give the option to do inflow or outflow depending on the purpose. So that's just my thought, but I don't see the math that you do guys behind it. But for transparency, for public, it's always easier to know, oh, that reservoir is full or it's not full. And I don't have to worry about this inflow, outflow, because that's not transparent to me as a public if I want to know about how water is being used somewhere else than in my pond.
Okay, thank you, Daniela. Are there any other questions up to this on-stream reservoir? I see there's a comment about having no way to calibrate the volume up to the height of the staff gauge in our large shallow reservoir. And that's why if you have a staff gauge, you also have to have a stage capacity table that can relate the storage or the stage in the reservoir to the storage. And I'm not aware of your particular case, but if it's an off-stream reservoir, the way the rules are currently written, I guess you could choose to do one of the other two alternatives. But Scott, did you want to go ahead? Do you want to unmute yourself, Scott, or can he?
Oh, there we go. Yeah, so there's no way we can do the 6.1.9.2. So we would have to use 1 and 3. So I think that, the way you have it set up makes sense for our situation. And I guess the other comment I have is, and I think we discussed this at our dam safety meeting in the spring with your engineer, you guys would have some means of calibrating evaporation, evapotranspiration, someone out of a reservoir or some sort of table based on the surface area of a reservoir. True story.
Yes, we've got standard evaporation. They're not isohydals, but they're like contour lines or isohydals that would show how much evaporation at each location there is. And then based on elevation, we can adjust that and ice cover as well.
Sounds good.
Okay, well, if there aren't other questions to that point, we'll keep moving on here. So the recording device functional standard. So a recording device can be required by the division engineer if necessary. It's also probably more commonly required in decrees for augmentation plans and other things that need a continuous recorder. This standard is intended to just define what would be required if a recording device is required, or what's the functional standard for that. And primarily, we would need it to be reading at no greater than 15-minute intervals, capable of accurate and continuous recording of flow rates in accordance with the standards in the previous rule. So the accuracy standards in the previous rule. And then it must include a means to verify that the recording device is properly calibrated. So this is only in the instance that a recording device has been deemed to be required by the division engineer. In some basins in the state, we have many different, a significant portion of the structures in the South Platte have recording devices on them because of the need for administration. But James, maybe, I don't know if you want to speak to the places where you see this in your division.
It's not very many. Recording devices aren't prevalent like they are in the South Platte. Our larger structures are the ones that typically have recording devices, and the ones that we need the real-time data for administration, especially of like the Cameo call, that those large structures down in the Grand Valley have measuring devices that have recorders on them and are telemetered, so we can get that data as we need it.
Thanks, James. So moving on to temporary measurement methods. So there is, we realize that the real world, sometimes your structure washes out. There's a flood, there's some issue with the structure that maybe it completely got tweaked over the wintertime, but freeze thaw, and you can't replace it right away. The temporary measurement method rule in 6.3 is intended to allow for a temporary period of time for a different measurement method to be used by for that structure. Not intended to be a long-term, because that method could be just a defined, distance and a stick, measurement or something to that effect for the short period of time that it's allowed. But recognizing that the real world doesn't always fit in a nice, neat box where everything stays working all the time, I think this is an important one. And then 6.4.1 is another important one, because that is where we define that if a measuring device is properly installed and maintained, has a standard rating table, an adjusted standard rating table. So that is the case where maybe we've provided a shift, or you have a shift for your device because of some issue with it that it's not reading accurately, but it's consistent shift. So that's that adjusted standard rating table, or a custom rating table that we've accepted, or the division engineer has accepted. The division engineer shall presume that the measuring device is accurate and no verification will be required. So this is going to be the case for many structures that they inventory, where they know it's accurate, they know it's installed properly, and then basically, hopefully we would be getting you a notice, but as we'll talk about shortly, and Andy mentioned, it's the owner's ultimate responsibility to make sure that that is confirmed. But the division engineer may ask for a verification, or the commissioners may ask for a verification at any time if they have a reason to believe that it's measuring inaccurately. And then 6.4.3 is the one I mentioned a couple times, where if you have an alternative measurement method, it needs to be rated or verified every 4 years. So that's either with a qualified tester submitting us a measurement that verifies that it serves as verification, or if usually it's going to be the user supplied if it's an alternative measurement method. So all flow measuring equipment used by a qualified tester. So if you have somebody else do these measurements, they need to be using devices that are calibrated. So there is both a requirement for pipe metering equipment and for current meters and acoustic velocity profilers that qualified testers might use to rate those for calibration. And we would expect those would be submitted when they submit a measurement. So let's see, Rule 7. To comply with these rules, each measurement method must be approved by the water commissioner. And this is where we are James' staff have been doing an inventory. I don't know if you want to talk a little bit about that, but
Sure, I can. We've had our water commissioners over the last couple of years as we saw these rules forthcoming and seeing what was being done in some of the other basins. The water commissioners have gone out, collected information about what measuring devices are installed in what structures, their sizes, and then if they had any questions about the reliability or accuracy of those measuring devices, have called out our hydrographers to do structure evaluations. So we've applied shifts to several structures over the last couple of years, which hopefully stay consistent. And if they do, then those structures and measuring devices will likely comply. If we get variable shifts from year to year, we'll probably ask the water users to reset those measuring devices so that they don't shift from one year to the next.
thanks. So then 7.1 is what Andy kind of covered already, that it's the ultimate responsibility of the water user to confirm the water commissioner's or division engineer's approval. So if you haven't heard, we're going to talk about the phase-in timelines here later. Don't hesitate to contact your commissioner or the division office. And then there's some specifics there about that, but that I don't think we need to read through. But so data recording and data submission. So the division engineer does have the authority to require water users to record and report at reasonable times data for diversions, and that's an authority by statute. We haven't typically, as James explained in the presentation, we have a lot of structures that are primarily measured by water commissioners. But we have areas, and maybe James can explain his biggest area. Is it every 2 weeks or every 1 week that your commissioner gets around?
It really depends on the area and how many structures are assigned. Some of our water commissioners have 1,700 structures that they're providing diversion records for on an annual basis. So they can't get to all of those every week for sure. It takes a month or more to get through most of them.
So in those cases, it's actually it's beneficial to the users to submit user supplied data, because if we haven't gotten there at the time when maybe the max flow occurred or when you had a big change in flow, it behooves you to have good record in our database. And so we would encourage you at least to submit data in those different ways that James talked about during the presentation. And if you have questions about that, you can contact James or your water commissioner, and they can help you out with how to get that in. Rule 9, this is the opportunity that users have to submit an inactivation form to declare that they don't want to use the structure for a period of time. And so this is if you have a structure that you're not planning on using for a while, and you got to notice that the measuring device is not installed or not adequate, and you must install one. If you have a plan to maybe put one in a number of years, you could declare it inactive, and then we will not continue to send you notice that your device does not comply. The question that has been asked at some of the other meetings is, how does that affect abandonment? Well, it's not a presumption of abandonment or intent is defined as 10 years of non-use. So just submitting an inactivation form does not satisfy that. But if you inactivate it and you leave it inactive for a long period of time, then just like any other structure that doesn't have a diversion record, it could end up getting pulled out on our database pull when we start that process, which in Division 5 now is not till 2035, but
Just one clarification on the inactive diversion structures. If you do inactivate your diversion structure, you will not be able to divert water.
Yes. So, yeah, and if you do divert water, then James's commissioners are probably going to bring out the lock. So under non-compliance, what happens if we don't have compliance with the rule? And so currently, I think I mentioned earlier, our efforts to send orders to people to order them to install measuring devices. So that's one option. If there's not compliance by the phase-in period, we may send you an order. I would assume we would have spoken with you already about it and determined that there's not really an intent to comply. And so the other option is that, we could refuse to deliver water if you don't have a measuring device that complies with these rules. James already mentioned that if it's a call situation and you attempt to place a call with a structure that doesn't have a measuring device, we're not going to honor your call. If you're upstream of the calling water right and you don't have a measuring device, we're already likely not going to let you take water unless we can pretty accurately know that we're going to still be able to satisfy that senior and water is, capable of going into those structures. So those are really our two compliance hooks to get people to comply with these rules. Variances. So there is a process under Rule 11 where you could request a variance if there's a practical difficulty or undue hardship in complying with the rule. The division engineer can grant a variance for specific instances. So you would essentially explain what that hardship is to the division office, and they would evaluate whether a variance is appropriate. So these other things, there's a process to appeal a decision under the rules. We have procedural rules that allow you to do that. And then the phase-in period, I think, is the last one I want to cover, and I'm going to have James cover the phase-in period.
Sure. So I've already talked with my water commissioners about the number of structures that they've got in place that have measuring devices and their thought process to do their side of the inventory, which will take a considerable amount of effort on our end. And then the structures that aren't in compliance with these measuring rules yet will have a timeline to get into compliance as well. So what we're looking at is for any diversion structure greater than 5 CFS, we'll have a 12-month phase-in period after the effective date. Measurement structures or structures that carry water between 2 CFS and 5 CFS will have 24 months or 2 years after the effective date. And then for the smallest structures diverting less than 2 CFS, they'll have 3 years for compliance. And then similarly for reservoirs greater than 5 acre-feet in storage will have 24 months to become compliant, and reservoirs with less than 5 acre-feet will have 48 months to become compliant. And then the effective date of the rules, the earliest that those will be is November 1st, 2026. So a year from now, assuming the water court process goes smoothly and the judge signs off on them before that date, that would be the first date that these become effective. So we'll have about 2 years from now before we hit our first deadline. And then for most irrigation structures, which are most of our structures, it'll also give you about 6 more months before you really need to be in compliance through that next winter period anyways. So we're trying to give you as much time to come into compliance with these as is reasonable and give our staff enough time. Please let us know if these phase-in timeframes are not sufficient. This is one place of these rules where we have a lot of flexibility to adjust.